It's now time to fix some of the issues that we had with our first version and in the previous video. You'll first notice that this main here is quite modular. We first create a list, print it, ask the user for an integer to be deleted, get the integer from the keyboard, delete it, and print out our new list. And without knowing the details of any one of these methods, it's pretty easy to read this main and understand what it does. So this is one of the main reasons to make your code modular, to make it easy to read. And then if I want to know exactly how the list is created, I can read through that method. If I want to know how it's deleted, I can read through that method. So create list we did before, print list we did before, delete node is the only new method here. So let's look at it. It takes as parameter the head of the list and the number that's going to be deleted from the list. Of course, we'll delete a node, so we'll delete the node that contains that number. And we're going to use a Boolean to help us here to know if we actually had that number in the list. So we'll start the usual way, making a temp and pointing it at head. So temp equals head. And if num is the item in head, and you'll remember we have to cast it. So if the integer that we're looking for is the item that's in head, then all I have to do is move head on, because the head was the node that needed to be deleted. Otherwise, we're going to look for this number in the list. So while temp.next is not null and temp.next.item is not the one we're looking for, move temp on. Let's see if we can find that on a whiteboard. So we'll start out making temp point at head, which was up here, and that if was false because the number we were looking for, and let's imagine it's the 4, the number we were looking for is not in the head, and so I'm in this while loop. So while temp.next is not null, well, here is temp, and temp.next is this one here, and temp.next is not null. Incidentally, temp.next will be null when temp is pointing at the last, look here, the one with the 16 in it. When temp points at this last node, temp.next is null. So as long as I'm not at the last node and temp.next item is not the one I'm looking for, so in this case 7 is not the one I'm looking for, then temp equals temp.next. So move it along, move temp along. Okay, back to the top of the while loop. Well, temp.next is not null. Temp.next is pointing to the node with the 4 in it. And temp.next.item, temp.next.item is a 4. And that is the one we're looking for. So I am now out of this loop. I do not move temp. I'm out of this loop. If temp.next is not null, so if I am not at the last thing in the list, found is true. So making found to be true. So I'm using this Boolean, which will become true if the integer I'm looking for is in the list. Remember this if found is false. So if found is false, I never found the thing I was looking for, and I am ready here to print, sorry, the integer was not in the list. If found is true, then temp.next is temp.next.next. So here is that piece of code. So temp.next is this pointer here. This is temps next. Temp.next is temp.next.next. Temp.next is this one. Temp.next.next is this one. So that means that this points here. So temp.next no longer is pointing here, but instead points to the one after. So I'll never be able to get to the one with the 4 in it because it doesn't have a name and there's nothing pointing to it, so I can't get there. All I can do is go from the head to the one with the 7 in it and then to the one with the 16 in it. So that was how we handled if it wasn't found, I'm just going to say the integer wasn't in the list, otherwise delete it. And then I have to return the head of the list, because if I don't, the changes that I just made will not be carried through to main. So we made it more modular, and we also checked that the number that we were looking for was actually in the list, and we're able to tell the user if it wasn't in the list.